And if you're gone, there may not be a lot of videos. I'll video sometimes, but sometimes if we're just working, obviously not. But if it's just some questions on certain packets, so I may or may not record it, whatever. Since there's not really a lot of new stuff, but some of that we go over. So this week, we have school on Wednesday, right? You guys know. There's a track meet I'll be on for Thursday. So I don't know. Right now, I'm leaning towards maybe the first of our finals being next week instead of this week, just because it's kind of disjointed here a little bit. And have a couple next week, and then probably a couple the week after that. Then we're getting down towards the end of the little, and then we may start working on that last set of problems. We'll kind of see how many days, how the days are fitting in there. So I want to, before we get started, I want to make sure. So that's kind of sample 4 and this sample 5. So I want to spend a little bit of time, probably a lot of time tomorrow. We'll talk about that sample 5, and that's the no calculator ones, and then give you the. I decided to break up that sample 5 a little bit. I don't know why, but since you got so many packets already, a few less pages. But so we can just focus on the no calculator ones because it. And I don't know which of the quizzes we'll get first. I like to be here for the calculator ones just because it's sub. So in case we do one on a day I'm going for track meet, the sub can't figure out the rest of the calculator stuff, with the hats and everything. So it's possible that I could be before the no calculator, but we'll see. So, but the multiple choice will be first, and then it'll be the free response after that. So I want to make sure we get a chance to. We've practiced and we've had some of these packets with multiple choice. We haven't had a lot of time to go over them or talk about them. So I'm going to do that a little bit here. So that 2017 I just handed back, we might take a look at that just a little bit because I don't think I really gave you too much time to ask questions on that before we hand it in. And I want to do a little bit of both. I want you to work on them without my help and so I can take a look at it a little bit and then we can go back. I didn't go and make any marks on them or anything. I just kind of skimmed through it and looked at it, kind of like I do with homework. I'm kind of keeping track of those points. That's going to go into homework grade as we get going here. So any questions on this before we hand this one in? Just because I want a chance to talk. This is just a front and a back here. Any questions here? Yes. 2B. Okay. Range. Yeah. So if you look at this, now this has this x plus 2 in it, okay? It doesn't change things a whole lot. It changes a little bit, but not a whole lot. So this is little f here, and so we know h is what? The what? Antiderivative, right? So, and this is going to come up in the free response section. When we see that, right away we think antiderivative. So h is the antiderivative. So somebody came in this morning, sorry from the other class came this morning and wanted to draw a graph of h. They thought that would help them with the domain and range. And potentially that could help you with that. But right away you think antiderivative, okay? And so I suppose you could try to write equations for this and do antiderivative. That'd be a possibility if you want to get into that. If they ask you for an equation for what h was, you actually could do that. I mean, here it's y equals 2, so the antiderivative of that, 2x plus c, you can plug in initial condition, because you do have an initial condition, don't you? H of what do you know the value of?
-2.
H of -2 is 0. Now that's where this was a little bit weird. Usually we look at the left endpoint, we'd say h of 0 is 0, but that's when it was 0 to x, right? So if you put a -2 right there, then you would have the area from 0 to 0, which of course would be 0. So it's a -2. H of -2 is actually 0. And you could also look at this as a shift of a shift, right? You can think of it as shift to the left. So the equivalent graph of that would be something like that. But anyway, that's all kind of side point. So what's the domain of h? I know you didn't ask about a, but it kind of goes along here a little bit. So on a, since this is only defined from -5 to 5, so we can only find areas from when x goes from -5 to 5, you could put -5 to 5 in here, right? So in other words, if you put we could do an area, not that we can only put -5 in here, but we can do an area from 0 to -5. So what does that mean x could be on the h graph and still be able to find an area? -7, right? So x could be -7, and then, so we could do h of -7, and that would be the area from 0 to -5, which we could do. That'd be this area right back here. Okay, so that's the smallest x could be, right? Because if we go -8, well, then we'd be trying to do the area from 0 to -6. We can't do that because this function is not defined. And likewise, we can do the area from 0 to 5. So that tells you x could be what? X could be as big as 3, but x can't be bigger than that, right? X can't be 4, because then you'd be doing the area from 0 to 6, and we can't do the area from 0 to 6. Okay? So the domain here would be -7 to 3. Okay, but now the range. So the range, we want to know what the outputs are. Now remember, h is area. So what are the possible areas we could get out? Well, this would kind of go along with finding max and min. If you can find the highest output and the lowest output, wouldn't that pretty much give you the range? So this is really a global max min question is what this is. Okay, well, let's review that. H prime, well, where would we look for a global max min? We would look at our endpoints, so let's do this. So let's do a list of candidates, okay? And so we would want to check h at endpoints. So we'd want to check h of -7. We would want to check h of 3. And we would want to, so we want to check the endpoints. We want to check when, what? The derivative, which means h prime, but h prime is the same as little f. We want to check when that is 0. Well, that's right there. So we're going to want to check there. And we're going to check where h prime is undefined. Where is little f ever undefined? Now, careful. Little f. Is little f ever undefined? Yes or no? Well, outside of -5 to 5, right? But from -5 to 5. So, what do you got here? So, that's fine though, because this is h we're talking about, right? So where is little f undefined? We'd say never. Now don't worry about those sharp points, right? Because that would be f prime. That'd be the derivative of f. This is the f graph. This graph is never undefined. This graph has values everywhere.
H of -2. Because it would be f0.
Oh, that packet. You got that packet, right? We handed in. We're looking at the 2000. Or we're looking at that worksheet 3 right now, but all we handed in was a 2015. Okay. Now, so the question is the -2. No, that's because, see, that's h of -2, not f of -2. You see what I'm saying? H of -2 would be the area from 0 to 0. But we're talking about h prime being 0, which means f being 0, right? So where is little f? This is the graph of little f, so little f has outputs of 0 right there. That's 0, yep. So that's the difference between those. There. Okay? All right. So, let's check out those values. So, h of -7, remember, if you put a -7 right here, you put a -7 right here. So that would be the area from 0 to -5. Well, that'd be this triangle. What is that? That's 1, 2 boxes, 3, 4, 5, 6, 7, 8. Positive or negative? That'd be negative, right? Because we're going backwards. So here's a box, here's half a box, or a 2 by 2 triangle. If you want to do that, 4, half that's 2, 3, 4, 5, 6, 7, 8. It'd be -8. Okay? I don't know why I did a T chart there. So h of -7 is -8. Okay? And what's h of 3? Well, that'd be the area from 0 to 5. Well, that's this area. There's a half, 1, 2, 3, 4. So 4.5, and that would be negative. So negative 4.5. And then 0. That would be the area from 0 to 2. 0 to 2 is negative 1.5.
That's why I was asking about -2, because wouldn't h of -2 be 0?
No. Which is bigger than any of those areas we have. Okay, so where yeah, we got it. The x plus 2, that's still h prime, okay. H prime of x, let's put this in here, would that equal f of x? The question is, or
That shifted to
yeah, h is the f graph. So what you're saying is we need to plug in not 0 here, but -2.
Okay.
Well, let's do it this way. This will help us make sense of this, and I think you're on the right track. Obviously, that is not the max value. Okay, let's go at it this way. Remember when we were talking about drawing the antiderivative graph and starting on the left edge and going that way? It didn't matter where the left endpoint was, even though the left endpoint is 0. So let's just remember we would slide that thing. We'd get the orange, and we'd either lose negative or gain positive, that kind of stuff. So let's say we were going this way. We'd be picking up what kind of area? As we go left to right, picking up positive area. So back here at -7, we're getting -8. But you're right, because the problem is I'm talking about area we're picking up from -5, but we're actually starting at -7, aren't we? So the whole thing is shifted over, right? So we do have to take that into account more than I thought. I'll be honest, I've never seen an x plus 2 on any of the AP tests we do. Usually it's like a 2x, and that's where you have to multiply by 2. You have to kick out a 2 and do something. So on x plus 2, we don't have to kick out anything, but we do have to take into account this shift. So as we're picking up this area, it'd really be from -7 to here. We're picking up positive, we're gaining until right there, right? On the shifted graph, right? Which would be right to there. So we're picking up area, and then we start losing area after that, okay? And so it starts going down. So our max value should be right at -2, which we already know h of -2 is 0, okay? So what is with those values, what's our range got to be? From -8 to 0.
That means if the entire thing shifted over 2, would you actually get some negative or some positive area, because from that 0 to 2 that'd be shifted over as well. That would make sense. Because then the entire thing would be shifted, so then you'd actually have some.
I don't think so, because right when this crosses is when it shifts, and when it starts going back down. See what I mean? And so I don't think you're going to get any positive area, right?
You don't.
And then that's when the key hits 0.
Right.
And so from -2 to 0 would be 0 to 2.
Yeah, so that
An
area
actual
would
graph.
yeah.
It'd be a little bit positive. It's negative, negative.
Yeah, because you get negative.
Yeah.
No, because
Oh, no, it's not, okay.
It's, because it would still be underneath, it would be negative, yeah. No, this has gotta be the max
Okay.
area you can get, well, I've got an answer sheet.
I think the thing is, it's f of t, not f of x.
Right.
T is x plus 2, so really it's h prime is equal to f of x plus 2.
Well, see, that's where I was going with this down here. So H, yeah, it's hard to write that. It'd be, yeah, essentially, if you would do this, basically what we're saying is that. The other way around. This is X. No.
Because it should be f of t.
Right, but once we do the derivative of it, it goes to an X, but it would go to, you're right, with this plugged in. So this has got to be the plus 2. Okay? Let me show you, let me show you an example. This will make more sense here. If I show you an example that we did early on with an X squared in there, and it looked like this. Okay, so let me pull this up. Okay, so what we were just saying there is the integral, so we got h of x equals 0 to x plus 2, because I kind of botched this up, so let's make this make a little sense here. Okay, so here's what we had. We did a problem early on where we had the integral from 0 to x, let's call it g, so we're not confused here. Let's call it g of x equals this, and then we had little f of t dt. Okay, then I ask you the question, what's g of x squared? What's the derivative of g of x squared? Was the question asked. Okay, so what we said is, forget this for a minute. How would you do the derivative of this? Well, you do the derivative of big G, which would be G prime. You would do what with the inside? Leave it alone, and then you would tack on a 2x, right? So then we said, where you'll see that on the AP test is you'll see this. You'll see the integral from 0 to x squared of little f of t dt, and then they'll ask you to do the derivative of that. Right? Well, so what do you have to do? What you do is you take little f, you have to plug this into it, right? You have to plug this into little f, because remember when we said what happens to the t in this case, when we do the derivative of this, we get little f out, right? And then what happens to the t? What do you put in place of the t? You put the x, right? And then you get little f of x. And that's what we run into 90% of the time, 95% of the time, maybe even more, where we just have a little x up here, okay? But if it's something other than x, we have to put the x into there, the something else. So in the problem we did in class was an x squared. We got to put the x squared in there, and then we got times by the derivative of that. Well, look, isn't that the same as that right there? Because isn't big G prime the same as little f, right? So see what I did? So if I'm doing the derivative of this thing, then what I get is this thing with this plugged in, and then the derivative of that. So now let's take that up to our problem. And I should have botched this a bit. So if I want to do h prime of x, then that should be what? That should be the derivative of this. So it should be what? Little f, x plus 2, and then times the derivative of that 1. So earlier, when I said we got this x plus 2 there, but we don't have to worry about it, that was a misstatement by me. What I was thinking was this part we don't have to worry about, right? The derivative of the x plus 2 is going to be 1, so that's not going to affect anything. But what I wasn't thinking of was the x plus 2 is going to affect that. So it is true in this problem to say h prime is, and that's good. I haven't seen that very often. Usually we see it in this context. So that shift does play a role. Okay, so back to this. So now, if h prime of x is equal to little f of x plus 2, then that makes a difference. Okay, so that means we need to take little f. So if we're going to answer questions about h and want to know where h prime is 0, we got to think of little f shifted and being back, let's see, what is it? Here like this. Right? And then, so if we're going to ask, and that's why it's negative 7 to 3, right? This would be the little f graph shifted back that way. So now it makes more sense. So now our h of negative 7, it kind of makes sense. What would we get? Okay, so negative 8 to 0. So by the way, that is the right answer. The negative 8 to 0 would be the range. Okay? Yes.
That, like from 0 to like -2, isn't that a negative area because it's like starts at 0? So it actually be a little smaller than -2.
If this said 0 to x, then you could go with that. Okay? Because again, it matters what are we putting in for x, and when we put it in here, you get that shift, and that's what makes a difference. Okay, and then the x coordinates of the relative extreme, and that doesn't. That would be what, like we said, at x equals -2, right? Would be that local max. All right, and then the minimums, and it asks for relatives, so there wouldn't be any local maximums, those would be at the endpoints. The local minimums would be at the endpoint, because this graph's going to go up and then it's going to go down. So it's basically just going to have a local max at -2. Okay, is that it for that one? Okay, what else? 3, anything on 3? That one was obviously the tricky one because of the, and here you can actually calculate these because you got half circles, so pi r squared, 1/2 pi r squared, that kind of thing. Okay, that was more than one time I wasn't going to spend on that, but actually it was valuable time because those do show up. Okay, anything else? All right, so set those aside and we'll pick those up here. All right, let's move to the motion packet. The motion packet. Everybody find that okay the other day? Okay, and again, this part of the motion packet, of course, the big one we talked about, the main one, well, let's just talk about the very first page you were supposed to do, page 21. Let's go over a couple things there. Okay, so when we're using an integral and we're doing motion problems, okay, I think my main goal here over this week as we lead into our finals is to really hit on the big topics. Now, we're going to run into some little things like that example we just did with the +2. Chances are in the final one question, somewhere in multiple choice, one part of one question, not very many points. You miss that, in the scale, with the scale and everything, you're going to be just fine. However, if you get that, that's nice. If you can get some of those things, but we want to really make sure we take care of what should be the easier points to get, okay? So there are 3 ways to use the integral. The integral velocity is what'd you put in here? Indefinite integral. It will give you an expression for, the word we'd want to use is position. Usually we use x of t for that. Sometimes it's p, sometimes it's y if it's up and down motion, but usually it's motion on the x-axis. But it will give you an expression for position is the word we want to use. Don't forget that you will have a blank, the value where you can know the position. What would we call that? Initial condition. Some sort of starting value. Or you can just say probably the answer to look for is a c or a constant if you have an antiderivative. But you'll have some initial condition. The value of c can be determined if you know a position value at a particular time. So if you have initial condition. Okay? This one is a definite integral. The answer will be a number. The number represents a change in position, so that's net change or displacement we talked about by fundamental theorem. The integral will give you x of b minus x of a, right? The antiderivative, we said that's why that's displacement, because it's your ending position minus your beginning position. Okay? This is known as displacement. It can be positive or negative, depending on if the particle lands to the right or the left of its original position. Okay? And then this is also a definite integral, so the answer will be a number, but this represents the total distance traveled. And sometimes they don't put the word total in there. Sometimes they just say find the distance traveled. That means total distance. Okay? The distance traveled means total distance. Okay? If they want displacement, they would say displacement. They might say find the change in position. Okay, that's what it is. So an integral normally is a change in value. So if you have a problem that doesn't have to do with motion, let's say these come up all the time on the AP test. They give you, I don't know, we had one. I think we had one the other day. Let's see. Let's look at the one you just that I just gave you back, the 2017. Here, the very first problem on here. Okay, no, let's see, maybe it's not the very first problem. No, it's not. This one with the bananas. The bananas. Okay, they give you that customers are removing bananas from the table at this rate. So if you do an integral, that will give you the change in the number of bananas. Okay, from its starting to its beginning. If you just do an integral of that, that will give you the change in bananas. How many were removed? Okay, it will not give you how many bananas are on the table, but it will give you the change in number of bananas beginning, subtracted from the number at the end. Okay, the change in bananas, and then they start adding bananas to the table. So the integral of that will give you the change in, what was added. So if it's positive, they were added to the table. If it's negative, there's less. Okay? So it's important to understand that concept. We see it over and over and over again in these problems. Okay? And the answer should always be positive on this one, total distance traveled. Okay, so that was kind of important. But any of those that were tricky or you had any issues with on any of those things? And maybe you don't have them all done. That's one of the things you could be working on, those other, as we get going. Okay? All right, so quick review of that. Sample, let's open up sample 4 then, if you would. Oh, wait, by the way, sample, while we're talking about it, free response 2017, the one I just gave you back. Okay? Did I give you yours, Ryan? Yeah. Okay. 2017, was there anything in that? I mean, it looked like most of you had answers for everything, and you probably worked together, whatever, but what
Number
4, B, and C. Now, yes. What's that?
We didn't do C.
Right, we didn't do C, but that was the one I added when we were reviewing for our last quiz, and I gave you that as a practice problem, and I threw it up there, but you guys didn't have your packets, they were already handed in, so you weren't able to do C. Okay? But we can talk about it here in a minute. So this is a differential equation one. So as we get closer to the free response ones, again, we'll keep coming back to these because there's 6 free response questions. And those 6 usually come from kind of our big ideas that we have. Max min, area, volume, differential equation. Those are really the big ones. And then they mix in sometimes with a table, sometimes with a graph, so you kind of predict what these are going to look like. So you said B and C. Okay, so first of all, we have this potato that is cooling. So we have this differential equation. It's actually a Newton's law of cooling. I mean, that's what it looks like. Now, whether you recognize that, it doesn't really matter. So in part B, it says use the second derivative. Now, it is related to part A. okay? Here we were supposed to do a tangent line. Now remember, all you need is a point and the slope to do a tangent line. Well, you know the point, h of 0 is 91, so all we need is h prime of 0. So that means we go up here and we just plug in a 91. Since there's no t, there's nowhere to plug the 0. So put a 91 up here. 91 minus 27 is, what, 64? And this is a no calculator one. 64 times -4 is -16. So we got our slope. We got our point. So there's our tangent line. Okay, it says use the second derivative to determine whether your answer part A is an under or over estimate. Did we do this one? We've probably done one like it, which is okay. This time of year, things should start looking familiar. What does the second derivative tell you? So as soon as you see that it's talking about second derivative, you should be thinking concavity. Now, if I got a graph that's concave up or concave down, and that's H, the H graph we're talking about. So, oh, and by the way, I didn't finish part A. Use this equation to approximate the internal temperature of the potato at time 3. So I guess this should really be a T here. So now put a 3 in there. -16 times 3 is -48. -48 plus 91 is 43 degrees. So we're approximating that to be 43 degrees using the line. Now, is that an under or over estimate? Oh, okay. So we have a tangent line to the graph, and now they're asking me about concavity. How does concavity come into play when it comes to over or under estimates? If H is concave down, then we know our tangent line is what? An overestimate. Because keep in mind what we did here. This tangent line was at t equals 0, but we found the temperature of the potato at t equals 3. Now remember, we put the 3 into the line equation. So we were not finding 43 degrees on the H equation, we were finding it on the line equation. So the actual temperature of the potato would be down here. So that 43 would be an overestimate. So what we need is our second derivative. So we need to come up here and we need to do the derivative of this. Okay, well, what's the derivative of that? That would be -1/4. And then what's the derivative of this? What's the derivative of H? H prime, and then 27 just would go away. So that's actually pretty easy. So H double prime would be that. So all we have to do is plug in our 0, well, not our 0, our 91. Doesn't really matter. Not 91, our -16. Sorry, we got to plug in H prime. Okay, so our H prime at 0 was -16. We don't know what it is at 3, but remember, we're trying to see at the tangent line what was the concavity. So at 0, what was the concavity? So we put our -16 in here, we get negative times negative, which is a positive. So since H double prime is positive, H is concave up. So since H is concave up, actually when we found our -43 right here, that's actually an underestimate of the temperature of the potato. The temperature of the potato would actually be a little more than that. So it is an underestimate. Because when H is concave up, the tangent line will be below the graph. And so this estimate we found here. So again, anytime it's telling you to use, I mean, this is just a good lesson in general. Anytime it says use the second derivative, it's concavity. That's what the second derivative tells you. Okay? Unless the question's about H prime, right? The second derivative, H double prime, would tell you about the slope of H prime. So, but we're talking about H here. Okay? And then don't worry about C, that's fine. Just because of time frame. I mean, we may come back and practice that again. Some of you already did it when we were getting ready for the other one. But that's where we can actually do a solution. We can actually separate variables, divide the G's over to this side, and do our separation variables. Okay, well, we'll get some more time for it. All right, finally, and I do want to give you some more time. Sample 4. Anything as we're hopefully getting close to get through this. We've had a few work days, but we've had some other things to do too, so maybe you haven't done a lot of things on that. So we'll focus here the next couple of days, today, tomorrow, in working in sample 4 and 5. Okay? That's our main focus. So for homework, trying to get some stuff done. We're going to spend time working in here. Tomorrow will be quite a bit of work.
Could you do number 7?
Okay. Number 7. So dy dx means which is y prime. So we need to find y prime. So that's one where it doesn't look like we could get y by itself maybe with some logs and stuff like that. But I would just say do the derivative of each side. So the derivative of e to the xy, remember e to anything is just itself, and then times the derivative of the inside. That means we got to take the derivative of x times y. How do we do that? Product rule, right? So derivative of x is 1, leave y alone, plus x, y prime. And remember, when we do the derivative of x, we just put 1. We don't put x prime. Because we're doing this with respect to x. So derivative of x with respect to x is 1. Okay? If this had been like a related rate we were doing with respect to t, then you could have had x primes and y primes. But not now. Okay, and then equals, and then what's the derivative of 2? 0. Okay? So now, normally, we would try to get y by itself. Right? If we were trying to find what y prime was, we'd try to get y by itself. That's going to be kind of tricky. We probably have to distribute this, and then get the y term on one side, but even with that, it gets kind of messy. But that's not, we don't have to do that, because they give us a point to plug in. So everywhere we see an x, we're going to put a 1, and everywhere we see a y, we're going to put an ln2. So this is going to be e to the 1 ln2, so I don't really need the 1, times, and then in place of the y, I put ln2. X is going to be a 1. What do we put in place of y prime? Oh, that's what we're trying to find. So we don't want to put anything in place of that. Right? And then equals 0. So we got, what's e to the ln2? 2. So 2 parentheses ln2 plus y prime equals 0. Distribute 2 ln2 plus 2y prime equals 0. So 2y prime equals negative 2 ln2 if you subtract that over, and then divide by 2, you get negative ln2, and it looks like you got that. And if they wanted to be really tricky, they could have done what with that negative ln2? What could they have done with this negative? They could have stuck it in there and made that ln2 to the negative 1, which is the same as 1/2, and so they could have written this ln 0.5. So they could have had, as one of their answers, ln 0.5. And when you got to this point, you would have had to have known that. They sometimes do that. Okay? All right. Good one. What else?
And can I stick with that to the value part on the
4. A lot of times with the absolute value part, you just draw it. Yeah, because the thing about absolute values, we really don't have a formula for the derivative when there's an absolute value, or even with areas. So what we do is we typically draw it. And remember, it might have been the other class. If you're given this and you're asked about slopes and stuff like that, like if you were asked for f prime, if this was f, and you were asked for f prime of negative 2. Well, that'd be an easy one. Let's put a couple of them up here. Let's say you're asked to find these two things right here without a calculator for that function. Okay? Well, we have no rule for this, derivative rule. So what you'd want to do is you'd want to say, okay, that's a parabola shifted down, down 4. You're thinking the minus 4 because of the v. I'm just looking at the x squared minus 4. So it's an x squared shifted down 4, so it would look like this. Now where would it cross? Right here and here. Would that be negative 2 and 2? Right? You put a 2 in here, 2 squared is 4, 4 minus 4 is 0, and then negative 2 also. And then what do we do to make, then what do the bars do? The negative flips up to positive. So now, here's your graph. Okay, the red. Now, what's f prime of negative 2? Your answer would be what? What's that slope right there? Undefined. So if they had asked you, if they had given you this f graph, now I'm getting off the rails here a little bit, we'll get back to this, it's easier. But if they had given you that, which they may very well do, I mean, they expect you to be able to know what a graph like of that would look like. So what you would do is you would graph this, okay? Now, f prime negative 2 is a pretty easy one then, if you can do that, because you can do, oh, it's a sharp point, that's just undefined. Okay, how would we find, and that would actually be, well, we can do it. Let's say they asked for f prime of negative 3, and they asked for f prime of 1 also. So let's talk about those. So at negative 3, and you were supposed to do that slope, what would you do? What's that? That's just the original parabola. This part right here is just the original parabola, I mean the one without the bars, right? That's just x squared minus 4. So what's the derivative of x squared minus 4? 2x, put in a negative 3, you get negative 6. So this would be negative 6. Now what about f prime of 1? That would be that slope right there. Isn't it just going to be opposite of the original parabola? All these y values just get flipped up. They're opposite. It turns out their slope is going to be opposite too. Their slope is going to be opposite too. So you could plug in in the original just 2x, or you could just say, well, that's just the opposite of the original graph. So the original graph was x squared minus 4. So the opposite of that is negative x squared plus 4, right? Now do the derivative of that. That's negative 2x. Put in a 1, you get negative 2. Slope would be negative 2. But you could just do the original parabola. Say the slope would have been 2 on the original parabola. You flip it up, it's going to be negative 2. Okay? So that's how we handle absolute value when it comes to derivatives. We don't do it with the absolute value. We do it without the absolute value, and then we adjust it accordingly. And I think graphs are a good way to do it. So looking at this. Now this one truly is just the V graph, right? This is just, so if I was looking at this problem, I would just say, well, that's a V graph, shifted 2 to the right and up 3, right? It's just going to be that. 2 to the right, up 3. So they want the slope at 2. Now that's one answer. Right? Does not exist. Okay? But and then it's 1 over here, the slope is 1 over here, and the slope is negative 1 over here. Right? If you got it. So, yeah. So I just think absolute value, you graph it. Okay? Same with an integral. If you were going to do the area, the area of this from 0 to 2, right? It would just be, whatever. It would just be that area. And then you just get right now. Well, that's a great question. Okay, so let's talk about area. Okay, on this one. Okay, let's go to this. This is definitely something that you could be asked to do. What about the area from? Let's do it from negative 2 to 2 of this graph right here. Now remember how we were talking about you do the absolute value of velocity, gives you total distance traveled, right? Now when we have our calculators, that's really easy because we can just type that in. So that's when that really becomes powerful and a good way to do total distance traveled. However, what if it's a no calculator situation and that's your V graph, whatever, and you had to do it? Okay, so Again, if we graph this, we know it comes down, goes like that, oops, then comes up like that. But from -2 to 2, we're talking about that area. That's not a circle, right? That's that part of parabola. What could you do to get that area? Well, you could, but even if you just go 0 to 2, and then flip it, right? I mean, again, you've got a choice. So what you could do, because here's the thing, okay? This graph, and I like what Matthew said a minute ago, this piece here and here just has the equation x squared minus 4. The blue piece has the equation what? -x squared plus 4. So you got an option. What Jaden said is perfectly fine. But the other option would be to just, the equation of that is just opposite. So this would just be doing this and do that right there. And that would give it to you. Or just do the original, like you said. Just do the -2 to 2, x squared minus 4. That should come out negative, right? It should come out, it would be this area down here. We can do that real quick. It'd be 1/3 x cubed minus 4x from -2 to 2. Put a 2 in there, you get 8. You get 8/3 minus 8. And then put a -2 in there, you get -8/3 plus 8. And so those are all negative. That would distribute. You get a negative answer, then just flip a positive, right? Just flip positive. So that would work too. So we could, you could be asked to do something like that without a calculator. This is how you would do it. This is how you do it. You look at that graph, you flip it up, and then you say, okay, this piece that we flipped is just opposite, or just do the normal, and then just say, but now, okay, so those would all be good ways to do that. Okay? Yeah, good stuff. All right. Let's stop right there. I want to let you work for a little bit here. So, but we will have. I'll give you more time to ask questions tomorrow. Sample 4, maybe getting into sample 5 a little bit too. But let's focus on those two things. Motion packet 2. We should be finished now because we may hand that in at some point. But so if you haven't gotten that one finished up, because we worked on that a lot the other day, and that was kind of the goal was to finish that up. So if you weren't here, you're behind a little bit maybe on that. Because I think a lot of you, it seemed like we're getting that done that day we worked on it. So, okay.